looking at that sample exercise, okay? It says refer to the periodic table and arrange as much as possible the atoms B, C, Al, and Si in order of increasing size, okay? So they're giving you so boron, carbon, aluminum, and silicon, and they want it in order of increasing size, okay? Which two, narrow it down. Two of them are going to be smaller and two of them are going to be bigger. How are you going to narrow that down in terms of bigger and smaller? Yeah, which period they're in, okay? For some reason my camera is really dull right now.
This is smallest to largest.
Yeah, so if you look at this, which two should be your biggest? Yeah, these are going to be bigger, right? And these two are going to be smaller. Why? These two end where? Be specific. 2p. Where do these two end? 3p. Okay? So automatically, we know approximately how we're going to set this up. The question is, these two are next to each other, and so are these. And yes, they did ask increasing size. And you have to be careful there, because they flip that around sometimes, where they'll ask for decreasing size and things like that. So read carefully. Increasing size means biggest one goes first. So out of these two, which one's going to be, or last? Biggest one goes last. I know. Out of those two, who's going to be the biggest? Al. Which means silicon's going to be second. Okay. And then, between boron and carbon, who's going to be bigger? Boron. And your smallest should be carbon. And does that fit with the answer they have? Yes. Okay. Now, try practice exercise 2. Same thing. Okay. Same concept, just different elements. So you're doing beryllium, carbon, potassium, and calcium in order of increasing atomic radius. Beryllium, carbon.
Go to the bathroom.
Sure. Quickly. Are you confident you have the right answer?
Yeah, I'm pretty confident.
Okay. All right. So, we're going in order of increasing size. So, which two should we be narrowing it down for, the smallest? B, E, and C. Out of those two, which one is going to be the smallest?
C.
It is carbon. Right? Why? It's further to the right. Okay? It's the second energy level. If it threw you off because BE is a 2s, keep in mind that's still on the second energy level, right? So carbon's going to be the smallest, then BE, then who?
Ca.
Then Ca, then potassium. Okay? All right? Okay. Now, we're going to talk about ions for a sec. I want you to think about, go back to lithium for a second. Okay, let me redraw lithium. So here's lithium, right? And we said it has 3 electrons, right? Lithium looks like this, doesn't it? Okay. Now, this is the lithium atom. What happens when lithium becomes an ion? It loses an electron. Which electron? The outer electron, okay? It loses the outer electron to become an ion, okay? What do we call that? What type of charge does lithium have now? It has a positive charge, right? And what type of ion is that?
Cation.
A cation, okay? How do you know? Because it's positive, right? Cations are positive, okay? I know, it's awkward, but you'll remember, okay? So, cations are positive. What happened size-wise to that ion compared to the original atom, which is called the parent atom?
It got smaller.
It got smaller. So cations are smaller than their parent atoms because why? They give away the electrons in that outer energy level, and now they have less energy levels, right? Yes?
Yeah.
Okay. I'm erasing. Can I erase? Because now I'm going to draw fluorine. Okay. How many protons does fluorine have? 9. Okay. Did I say proteins? I think I did. I meant protons. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9. What does fluorine want to do? It wants to gain 1, right? So fluorine wants to gain 1. We'll switch it up color-wise. Here, so now fluorine gains 1. So now it has more electrons. So now instead of being the fluorine atom, it is the fluoride ion, right? Which has an F, it's F minus. What type of ion is that? Anion. Okay, I don't have any cute little tricks for that. Other than it's kind of like the word onion, and onions make you cry, and crying's kind of negative, and blah, blah, blah. But really, if you just remember cations are positive, then you're all good to go. Okay, now, I got my kid pajamas that have a cat on them, and it says, like, positively awesome. He doesn't even know. All right. So they sold them at Old Navy. I was really excited. All right. Now, look. What's going to happen to the anion size-wise? It gets bigger. Why? This is important. We want to be able to explain why. So remember that purple electron was added in there. Why would the anion be bigger? Sebastian?
Because the electrons are repelling each other?
Yes, because you're adding an additional electron, which means there are more repulsions, right? Which means they're trying to spread out a little bit more than they were before to get away from that electron, right? So because you're adding another negative to the mix, and it's on that same level, they need to spread out to get away from each other, okay? So that's what happens. All right, now go to the bottom of page 265, and let's look at that sample exercise. It says Mg2+, Ca2+, and Ca in order of decreasing radius, okay? Decreasing radius. So take a minute and try to reason through that yourself. Mg2+, Ca2+, and Ca in order of decreasing radius. So if we're going decreasing, then we're going what? Big to small or small to big? Big to small. Okay. one of these is definitely our smallest. Who's it going to be? The magnesium. So I would just put that over here on the right. And then make sure you flip around your fishy.
I never got
Which part? The
I
greater and
remember
less?
doing this.
Like this? Or
No,
what?
like the decrease.
Oh.
Like when you have like the same element, but it had 2 plus, and then it had none. Like,
So think about what we just talked about with lithium, right? It gives away that outer, so does calcium. It gives away that whole outer thing.
so if it means 2 plus is a giveaway, it just gives away 1 still, right?
No, it gave away
Or
2. Because if you, so look at calcium.
Yeah.
It's number 20, right?
Right.
Who do all the elements want to be like?
Krypton.
No. Like which group
Like
do
the
all
noble
they all want to be like the noble gases, right? So you were in the right area. They're going to do that the easiest way possible. Numerically, who's calcium closer to in the noble gases?
Argon.
Argon. What does it have to do to be like argon? Lose 2. So it gives away 2. That's how it does it. Okay? All right. Is it the calcium ion or the calcium atom that's going to be smaller? Calcium ion. And then calcium. Did I do my fishies the right direction? Good. I always get these like confused in my mind. So if I was taking this test, I would just make sure to like write decrease in case I do my fishies wrong. You know? So that way you're being clear with words. All right, do the practice exercise number 2. Okay? S2 minus, SO2 minus. Number 2, at the very bottom. And they just want to know which one is the largest. They're asking the question a different way. You guys, these are really great multiple choice questions. Do you see all the different ways they can ask these? And they do. Honestly, there will probably be, I'm going to go with 7 to 10 multiple choice questions on periodic trends alone. It is potentially a really easy place to get some points, but you've got to be spot on, okay? So the more you practice this is one of those easier concepts that's heavily tested. Not all concepts are heavily tested. Periodic trends, heavily tested, okay?
I got a question.
Yeah.
Alright, so you remember that, like, hold on, let me draw it for you. Because I can't really explain it. I don't
Yeah,
know.
give me a second. Go ahead, Ross. I'll be right back. How important?
10 periodic tables.
Oh, sure. Come get them. Yeah, that's fine.
I didn't know if you were filming.
I am. So walk around your desk. Yeah, that's fine. Just, yeah. Okay, go ahead, Ross.
So, I remember doing this. This is like atomic radius, and that's like the biggest one, and this is ionization energy, and that's the biggest one. Is that like what we're doing?
Yeah, except we're looking at them individually
Right.
and not just by memorizing the trend, but understanding the why. Because then if you understand the why, it's easier. All right, so who's the biggest, you guys? Yeah, S2 minus. Why? It's an anion, so it's bigger than sulfur because you can't just say anion. Just heads up. You've got to be very specific. If this was like a free response question, what would you say? It didn't give away. It has 2 extra electrons, so there are more repulsions. Okay? Got it? You're on the right track. How come it wasn't O2 minus?
Because that's less energy level.
Yeah, that only goes to 2p, not 3p. That's why. Okay. All right. Good. So